Hello everyone. Today we are going to study the traveling salesman problem in the dynamic programming. What is the dynamic programming? It means that we find out the solution to a problem on the basis of a sequence of decisions. So multi-stage graph, all pair shortest path, 0-1 knapsack, traveling salesman. These are the applications of dynamic programming. Today we are going to discuss the traveling salesman problem. Basically what is happening in the traveling salesman problem, that I have to start from one city and I have to plan a tour. I have to travel. I have to plan a tour across different cities, and then I have to return back to my starting point. That is, suppose I started from city number A, I went to city B, C, D. I have to return back to city A, and I have to complete this tour in the minimum cost. My goal is to complete the tour in minimum cost. I have to reach my starting point again after traveling all the entire cities which are given in the graph. So let's see the conditions for the traveling salesman. We have a graph g is equal to v comma e, which is a directed graph, and each of the edges has a cost ci comma j, and whenever ci comma j, that is there is an edge, that is it belongs to the edge set e, then cost is greater than 0. And suppose for any of the two nodes or vertices I don't have an edge in between them, the cost is infinite. So my goal is to find the minimum cost tour. What is the cost tour? Sum of cost edges on particular tour. That is, suppose I start from here, cost tour will be cost edge of this plus cost edge of this plus cost edge of this plus cost edge of this one. So let us see a problem. First of all, for that, let us look at the formula for the traveling salesperson. We have to find a gi comma set s. What is this gi comma set s? It means length of shortest path starting at vertex I, going through all the vertices in S and terminating at vertex 1. That is, suppose I start from vertex 1. Okay, I have to always start from vertex 1. Suppose I go to vertex 2. Suppose I have this graph, or okay, suppose I have this graph. Now length of shortest path starting at vertex I, this is always included by default because I'm starting from here. So the first value of I will be 2. Okay, when I take 2, first value is 2. Now I have many possibilities. That is, the method of solving for the traveling salesman person is that first of all I take mod of s is equal to 0. That is, what does that mean? Let me show you the help of the question. Suppose this is my question, this is my given graph, and the cost matrix I've given it over here because it would be messy. It can also be written over here. There's nothing in that, but you have to see that it is a bidirectional, there are bidirectional arrows. So okay, so let's solve. First of all, we always solve for s mod s is equal to 0. That is, what is s? S is a set of vertices, and it means that how many edges are there between that vertex. Suppose I start from 2, between that vertex and the starting point. That is, how many vertices will I traverse in total. For example, s is equal to say 1. That is, if I'm standing at 2, I can cover one more vertex. I can cover one more vertex and then go back to 1. So suppose from 2 I have to cover one more vertex. What I will take? 1 is already included in the solution set. Why? Because I'm starting from 1. So if I have to start from 2, after 1 I go to 2, and from 2 I have to choose one vertex. I will choose the 3, I will choose the 4. Okay, so suppose my s is equal to 2. That means starting at any given vertex, that is starting at 2, I have to choose 2 more vertices and go back to my starting vertex. Starting vertex is 1. The main motive of traveling salesman is that after traveling everywhere, I have to reach back to my starting vertex. That is, I have taken here as 1. Okay, so let's see the question now. So we assume starting vertex is equal to 1. So since we have assumed the static vertex to be 1, so we are going to calculate for 1. We will calculate for rest of the vertices. So one more formula that we had to take care is that when for this thing, when there is no set in the set S, so directly the g of I comma phi is equal to cost between 1 between I and 1. Let's see how. So we have g of I is what? I is any starting vertex, 2 comma, right now S is equal to 0, that is phi. Okay, so that is equal to cost of 2 comma 1, and cost of 2 comma 1 is 5. Similarly, I find out g of 3 comma 5, and I find out g of 4 comma 5, that is cost of 3 comma 1, cost of 4 comma 1. 3 comma 1 is 6, 4 comma 1 is 8. Okay, so now let's do for S mod of S is equal to 1. That is when I start at any given vertex, I will have one vertex, that is from 2. I'll just show you here. That is from 2 I had 1, 2, 3 and 4. So from 2 I could go to 3 or I could go to 4. That is from 2 I can reach either 3 or I can reach either 4. In the same way, from 3 I can reach either 2 or I can reach either 4. Then in the same way, from 4 I can reach either 2 or I can reach either 3. So now as per the formula, this is equal to minimum of, this is I, this is S. So minimum of, and J will belong to S, right? So here J is equal to 3. J is belonging to S, so J is equal to 3. You have to see this part very, very carefully, because if you get confused now, you will not be able to solve the entire problem. See very carefully the values of I, J and the values that we'll write further on. Okay, so as per the formula, it is minimum of cost of I comma J plus G of J comma S minus J. Okay, so here it comes out to be minimum of, see, I comma J. I is 2, and what is the value of J? J belongs to S, and what is my S here? S is a set which contains 3. That is J is equal to 3 plus G of J is 3 comma S minus J. What is S? S is, my S is equal to 3, and what I have to subtract from it? I have to subtract from it a set which contains J. J was 3. That is, it comes out to be 5. So minimum of 2 comma cost of 2 comma 3 is what? Cost of 2 comma 3 is, you can check out from the graph, the cost of 2 comma 3 is 9. So cost of 2 comma 3 is equal to 9 plus G 3 comma 5, as we calculated in the previous part. G 3 comma 5 is 6. So I write down 6 over here. Okay, so it comes out to be what? 15. Similarly, I calculate for this part is equal to minimum of, here there's no need to find out minimum because we have only one value. So minimum of C I comma J plus G J comma S minus, you don't need to write the formula again and again. So cost of 2 comma 4 plus G of 2 comma, G of 4 comma 5, which is equal to 10 plus 18, that 10 plus 8, that is 18. Similarly, I find the cost for this thing, cost of I comma J plus G of J comma S minus J, that is 5, which comes out to be equal to 18 once again. Okay, now I find out the costs for sorry, the G for all these things also. I have already calculated. They come out to be 20, 13 and 15. Similar way. Now we are going to take for S is equal to 2. Okay, so for S is equal to 2, now what has happened? I can go from 1 2 3 4, right? From 2 to 2 other vertices, right? Like while doing my tour, I started from 1, I reached 2. Now from 2, I have earlier what I was doing, I was either when S was equal to 0, I was going back from 2 to 1. Okay, and now when S was equal to 1, I was taking any one of the cities out of these two. Now when S is equal to 2, I have to take both these cities along with 2 and then go back to 1. So what it comes out to be, G of 2 comma 3 comma 4. Now here I'll have to find out the minimum one. Minimum of cost of I comma j plus G of j comma S minus j. So that comes out to be minimum of I is what? 2 and j belongs to S, that is j is equal to 3, j is equal to 4. Once I take j as 3 and once I take j as 4 plus G of 3 comma S is what? 3 comma 4, j is what? 3. So 3 comma 4 minus 3, that will be 4 is remaining, and here it will be 4 comma 3. Okay, so the minimum out of these two, let's see, the minimum is this is 9 plus 20 comma, this you find out from the matrix given in the starting, and this we have calculated just now in the previous step where S is equal to 1, like here. J of 3 comma 4 is here 20. So we take the values from the previous stages. Okay, or I get 10 comma 15. So the is equal to minimum of 29 or 25. That comes out to be 25. So for j is equal to 4, I get a minimum value. Similarly, I find out for g 3 comma, now when it has reached vertex 3, 1 is already in the solution set, so now it has to go to 2 vertices, 2 and 4. So I find out minimum for C of 3 I comma, once I take j as 2, once I take j as 4. Okay, plus G of j comma, what is S? 2 comma 4, and what is j? 2. So S of 2 comma 4 minus 2 is 4, and C of 3 comma 4 plus G of 4 comma 2. So the result is minimum of 13 plus 18. This is 13, this is 18. We calculated out previously, and this we can find from the cost matrix. Sorry, yeah, from the cost matrix that is given in the beginning. 13 this is also minimum is, this is 25, and this is 8, 9, 10, 11, 31. So 25 is the minimum for j is equal to what? 4, right? Okay, so now the next we calculate for g 4 comma, it can go to 2 and 3. So I have already calculated it out. It comes out to be 23 for j is equal to 2. Now if I do I'm done for S is equal to S bar is mod of S is equal to 2. Now if I do S bar is equal to 3, now what is happening? I have to find, suppose I say I will find G of 2 comma 1 comma 2 3 comma 4. So but 1 is already in the solution set. This is the starting vertex, that is we cannot include here. That is, suppose it was 1 2 3 4, 1 is already traversed and I have to reach back at 1. Okay, so now from where from 2 where can I go? I can go to 3, I can go to 4, that is equal to S is equal to 2. Now I cannot go to 1. No, why? Because 1 is already traversed. In the starting only we have said that we are starting from vertex 1. So this is not required here. And what happens in the final stage? Now we have the final state. What happens? We find out G1 comma 2 3 4, that is minimum of C1 comma 2 plus G of 2 comma. Okay, how we found out this? This is I comma J. J is equal to 2, J is equal to 3, J is equal to 4. So we write down three cases here. J is equal to 3 and J is equal to 4. Okay, and here it is J comma S minus J. S here is 2 3 4 and J is 2. So 2 3 4 minus 2 is 3 4. I hope you know the subtraction of sets, right? That's simple subtraction of sets going on. Subtracting elements of this, subtracting these elements from this set. So I am left with only what am I doing? Subtracting 2 from this set. I am getting only these elements, right? S minus J. This is S, this is J. So when I remove J from S, when I will remove 2 from this set, I will get only 3 and 4. Similarly, I'll get here 2 and 4 and I'll get here 3 and 2. I find the answers for these. They come out to be 10 plus 25 or 15 plus 25 or 20 plus 25. For J is equal to 2, J is equal to 3 and J is equal to 4. This is obviously the minimum, that is 35. Okay, so that is 35 is the cost required to travel from 1 to 1 through and covering all vertices. Okay, and now we have to find out the root. So we backtrack. Okay, how we'll backtrack? From 1 we had started. Now which value of J was giving me the minimum to cost? 2 was giving, so I will go to 2. Okay, now I reach 2. When I reach 2 in stage in the previous stage than this, what has happened? In 2, which was the one giving, which value of J was giving me the minimum one? J is equal to 4. That is, after 2 I will go to 4. Okay, then when I reach, now S2 is over, now I will go back to S1. Now in S1 the value was 4, right? I will go directly to 4. So for 4, which value of J is giving me the answer? The value is 3. Here there was no criteria for finding the minimum because only one value was there. So for J is equal to 3. Okay, and so that is sorry, that was the next topic that we're going to discuss. Anyway, so after 4 we are going to go to 3, and then obviously after 3 we'll go back to 1. So let me tell you this step again. What is happening? Basically, we are finding the minimum value of J. When I calculated the G of 1, 2, 3, 4, I saw that for J is equal to 2, I got minimum cost. So that is, I traveled from 1 to 2. When I reached 2, I could go to 3 and 4. So when I reached to 2 and I traveled 3 and 4, I found that J was giving me minimum value with 4. J was giving me minimum value with 4, right? This was minimum, this was with 3, this was with 4. J was giving me minimum value with 4. That is why I went from 2 to 4. And when I went to 4, then here only one option. So when I went to 4, after that the value of J was 3, so I went to 3, and then obviously all my nodes have been covered, 1 2 3 and 1 2 3 4, and that is why I have to return back to my city 1. So that's all about the traveling salesman problem, and yeah, that's all. In the next now you can see that we're going to discuss another dynamic programming problem, that is the multi-stage graph. So see you then. I really hope you liked the video, and sorry for the little distractions in the video. Okay, please do like, subscribe and share, and it would be a great motivation for me. And you can mention your comments or any doubts below there in the section, and also mail me. You can mail me at lastminutetutorials.com @gmail.com. And that's all. Thank you for watching.